Good evening and welcome everybody. This is Obi-Wan Pez for Simplex Pachinko. We're going to have some math tonight. I think amongst the things that we're going to be looking at are going to be the actual individual problems that we're going to be assigning to our groups in the Differential Equations class, which I would like to get started. Well, I don't know exactly when that's going to happen, but lol. Okay. What I'd also like to do is to split the screen, but I have not been able to find a way to actually do that. So, yay. Because it's like under, it would be under view. I don't know if this is going to work, but, okay, it will. So if we do, no, no. Okay, cool. Doesn't appear to be a way to do it. That's fine. All right. So if we go and insert a page break. Woo! Alright, so session 1 is going to be about differential equations history. So if we go Alright, discuss the major contributors to differential equations invention. One sec. All right. So first off, we're going to ask for students to discuss the major contributors to the invention of differential equations. So we're going to talk about the invention of calculus being the big one. Let's also put in a second page. I don't know if there's a way to like hide stuff. Alright, so discuss major contributions to the invention of differential equations. We're going to talk about apologies. We had a bedroom tragedy with the state of somebody's bed. Goodness knows we can't do it ourselves. Right. So, discuss major contributions to the invention of differential equations. We're going to start with the invention of calculus being the big one. Of course, we have the two major contributors to the invention of calculus itself, Newton and Leibniz. And next question, where's my notebook? Because that would also help. Granted, I can get this done without it, but it'd be a lot easier if we have it. my complex analysis book. It's not the right one. Although, is that also my karate book? No. So anyway, how y'all doing? If anyone is hanging around, if you have any questions on mathematics type stuff, let me know, and I will get to you as soon as I can, barring any more interruptions, apparently. Yes, agreed. So pretty much any mathematician will agree with that statement. Physicists might argue that, well, they don't need anything else, so why not just stick with Newton notation? All right, so that's a fair point. So my talking points are going to include these several pieces, right? And we want to talk about the notation, but also to talk about types of differential equations. Had a guy come with the moving company that put all of this stuff here. He was working on the truck and basically like tearing all the stuff off the sides of the pallets and things like that, and then just handing things down to the guys as they were coming out. His name was Yorkie. I was like, well, that's a little on the nose. I'm like, all right. Well, at one point I said like, hey, I'm gonna go over across the street because there's a coffee place. I was like, if y'all want any sort of coffee, let me know. And I took down their orders. He was like, I don't really care as long as I can put whiskey in it. I was like, sir, it is 10 o'clock. Oh no. He was joking, but nonetheless, it was a moment. And It's like we have enough space out in front of our house, like that 2 cars could go past each other. And fortunately, they'd cleared out, like all the neighbors didn't have their cars because they were at work. Um, in like any of the side parking places, which are up, like you've got driveways on our side. The other side does not have driveways. They just have like a pavement that runs across their, runs in front of their houses, and they have to park in like the spaces. So Yorkie gets the big freaking giant truck in there, and yeah, he gets the big giant truck in there, and the guys are like, Yorkie, what do you think? You can get this out of here? He's like, no problem, yeah. Be able to turn this thing right here. Let me tell you, it's turn it on the spot. I'm like, all right, whatever you say, man. Not even gonna question it. Yeah, pretty much. Because, I mean, I can't properly do just about any accent. I can get close, but I need to hear it again. Because otherwise I'm gonna slip into fake Cockney. As evidenced. It's pretty much fake Cockney or fake posh at this point. All right. Has they got any white lightning per chance? Oh my goodness. That's the one guy in Fable that I really like running across every so often. I think it's actually Tony Robbins. Or if it's not Tony Robbins, it's somebody who sounds remarkably like him. Okay, so Newton and Leibniz notation, types of differential equations they dealt with. We had Bernoulli, all 3 of them. Pierre-Simon de Laplace. We had Joseph Louis Lagrange. I believe it was Lagrange who was the advisor to Napoleon. Somebody had, I think it was the Breaking Math podcast, or maybe Neil deGrasse Tyson on Star Talk was talking about when he took a dinner date at Napoleon's place, and Napoleon was doing something that was bombastic and trying to, like, you know, basically trying to say something that was interesting, and Lagrange was slightly surprised that he had read and allegedly understood, like celestial mechanics and things like that. It's probably Neil deGrasse Tyson. But I can't remember what the actual quote was now, why he brought it up. There was a slightly amusing quote, but this was also the same guy who authored a book on celestial mechanics and like how the universe works and differential equations, and how to use differential equations to solve all the problems that have been coming up in celestial mechanics. And Napoleon said basically, you know, I noticed that you didn't acknowledge the creator, and, you know, thank God for the inspiration, I suppose, or something like that, as was the practice of the time. Most scientists even put that in the front of their book, just, you know, inspiration, you know, inspiration to God. Thank you for creating all of this really cool. Thank you for creating the universe, essentially, and all of its majesty. And Lagrange said, Je n'ai besoin de cette hypothèse-là, which is, I had no need of that hypothesis. It's quite the thing that you want to say to an upstart emperor. Really, theirs are on the same sort of stuff Bernoulli's had. The Verkistochrome problem. Because why not? Yeah. We'll talk broadly about the time frames of each individual civilization's contributions. The French will feature very heavily in Differential Equations 1. Germans, Gauss, etc. Do get a bit more somewhat later on. Well, how about it, Sensation? You got any particular math problems tonight you want to work on? No stress if you don't. um, So first thing, we go with the smartass answer. If it's a differential equation, it's an equation with differentials in it. All right, so we want to look at the order. Nope. That's not our ordinality. Ordinarity. So we want to discuss the order. Sometimes people think of it or hear it as the degree. It kind of depends on where you learn it from, so won't hold anything against anybody there, definitely. The ordinarity, so is it an ordinary differential equation or a partial differential equation? Linearity, and then the homogeneity. Right, how are they same, how are they different? Right, so we're going to go here and we're going to say that this is Classification. And if we take the trench book, alright, population growth and decay. Going to be governed by differential equations. It's one of the first places that we really see it. See an application for differential equations, and again, this really started before anybody even touched calculus. I think I'll leave it in this order. This actually works better, I think. So we can trade around. Okay, 3, we wanted to talk about verification of differential equations themselves. So like, hey, given a differential equation, what if this is an answer? Or what if this is a proposed answer? How do you check? Oh. insert equation, and we're going to take something similar anyway. We don't have to necessarily be exactly the same. Okay, so hey, you kept it. Once again, if anybody has any questions, please feel free to drop them in chat, and I will get to it shortly. So let's do like an easy one. So y equals 5e to the 7t plus 7. Will be a solution to the differential equation. Y prime is equal to 7y. Okay. We'll go a few others. Maybe something we'll see a bit later. Not too much later. Something like a second order differential equation. Say, oops. Insert equation y equals 12e to the 0.1t is a solution to 100 y double prime minus 20 y prime plus y is equal to 0. Okay, good. Sometimes you just want to verify real quick, make sure you got the right thing. 0.01. Nope. And equation. M equals 0.01 e to the 3t you know what? Hang on. Let's see if yeah, I got a good one here. Okay, 0.01 t to the -4th plus 1/9. That's terrible. I don't want this to be like that too. There we go. 1 over 100 times. To the -4th plus 1/9 times t to the 5th. Okay, there we go. This is a solution to, let's do the notation this time, as annoying as it is. Yep, fraction dm dt not is equal to dm dt plus 4 over x. Right. I could just do these as fractions. God. Sort of. Plus fraction 4 over t, yep, times m is equal to x to the 4th. I want everybody to realize what I'm doing here. Let's not confuse a random. Okay. And one last one that is not particularly annoying to like. One that is not particularly annoying to verify, but would probably be impossible to solve. I don't want to do that one. A couple of these are entirely in very large form, so we're not playing that game. There's a couple in this book, I know, which would be practically impossible to solve. Just gotta figure out which ones. So, like, these are just regular. These are not too bad. This one might be interesting here, but it comes up with all that junk. So, okay. Like, I know 100% this will work, but at the same time, I look at it and I go, I don't know. Scaladra. It's doing something for Bognagus. He was looking at Star Citizen. He was trying to figure out some sort of way like that his team could strategize better, and I was like, dude, if the three of you came in to the center of a battle, cockpits in toward the center of a circle, like, you know, here, 1, 2, 3, all cockpits toward the center, then your field of view is like this massive overlapping area. They're not going to be able to get the drop on you. Not that you're worried about that necessarily. But then also, they're doing some dog fighting. So I was like, here's how you all need to think about it. Not need to, but Yeah, so I was thinking like if you're in this kind of triangular formation, there's only 3 people on a team, and again, get your cockpits to overlap each other, then like everybody's always flying. It's kind of ridiculous, but everybody's always flying like this, their tail sticking up like that, and there's no difference until they make contact, at which point they start veering off and doing whatever they're doing in all 3 dimensions. So I was just like,